Chapter 6, Section 2, Properties of Waves. The two questions are: what are the amplitude, wavelength, frequency, and speed of a wave? 2. How are frequency, wavelength, and speed related? What are the amplitude, wavelength, frequency, and speed of a wave? Waves may vary greatly. For example, waves can be long and short. They can carry a little energy or a lot of energy. They can be transverse or longitudinal. However, all waves have common properties: amplitude, wavelength, frequency, and speed. Amplitude describes how far the medium in a wave moves. Wavelength describes a wave's length, and frequency describes how often it occurs. Speed describes how quickly a wave moves. Amplitude. The height of a wave's crest depends on its amplitude. Amplitude is the maximum distance the medium vibrates from the rest position. For a water wave, the distance is how far the water particles move above or below the surface level of calm water. High waves have more energy than low waves. The more energy a wave has, the greater its amplitude. A transverse wave is shown in Figure 1. Its amplitude is the maximum distance the medium moves up or down from the rest position. The amplitude of a longitudinal wave is a measure of how compressed or rarefied the medium becomes. When the compressions are dense, it means the wave's amplitude is large. Wavelength. A wave travels a certain distance before it starts to repeat. The distance between two corresponding parts of a wave is its wavelength. You can find the wavelength of a transverse wave by measuring the distance from crest to crest, as shown in Figure 2. For a longitudinal wave, the wavelength is the distance between compressions. Frequency. The frequency of a wave is the number of waves that pass a given point in a certain amount of time. For example, if you make waves on a rope so that one wave passes by a point every second, the frequency is 1 wave per second. Move your hand up and down more quickly and you increase the frequency. Frequency is measured in units called hertz and is defined as the number of waves per second. A wave that occurs every second has a frequency of 1 wave per second, or 1 hertz. If 2 waves pass every second, the frequency is 2 waves per second, or 2 hertz. Speed. Different waves travel at different speeds. Think about watching a distant thunderstorm on a hot summer day. The thunder occurs the instant the lightning flashes, but the light and sound reach you seconds apart. This happens because light waves travel much faster than sound waves. In fact, light waves travel about 1,000,000 times faster than sound waves. The speed of a wave is how far the wave travels in a given amount of time. You can determine a wave's speed by dividing the distance it travels by the time it takes to travel that distance. Sound, for example, travels about 990 meters in 3 seconds. In air, when the temperature is 0 degrees Celsius. Therefore, its speed is 330 meters per second in these conditions. As long as the temperature of the medium, air, doesn't change, the speed of sound will stay the same. How are frequency, wavelength, and speed related? You just learned that you can calculate the speed of a wave by dividing the distance it travels by the time it takes to travel the distance. But you can also calculate the speed of a wave if you know its wavelength and frequency. The speed wavelength and frequency of a wave are related by a mathematical formula. Speed equals wavelength times frequency. If you know two quantities in the formula, you can calculate the third quantity. For example, if you know the wave's speed and wavelength, you can calculate frequency. If you know the speed and frequency, you can calculate wavelength. The speed of a wave remains constant in the medium. Temperature and pressure do not change. For example, all sound waves travel at the same speed in air at a given temperature and pressure. Even if a sound wave's frequency changes, its speed stays the same. So if the frequency of a sound wave increases, its wavelength must decrease to maintain a constant speed.